All right, the moment we've all been waiting for. Chapter 8, Section 3. Trigonometric ratios. Got a little hiccup in our giddy up. So you can pause and read the legend of Sokotoa, but I'm going to get to the point. Okay, so draw this triangle A, B, C. Label the angles capital A, capital B, capital C. Put the right angle in the corner. Across from the right angle is the hypotenuse, which is C. Across from A is side A, and across from B is side B. There's a beautiful thing that happens, and we give them a name. So I don't want you to be frightened as we are naming these things. So the fraction that is made by the side opposite and the hypotenuse of a triangle is called the sine of angle A. Sine, we abbreviate it S-I-N. Some of my students will say sin A, and I don't correct them, but it is correctly pronounced sine. It is the fraction that's created by the opposite side over the hypotenuse. Cosine is the fraction that is created, so cosine of the angle A. It's the fraction that's created when by putting the adjacent side over the hypotenuse. And the tangent of angle A is the fraction created by putting the adjacent side over, the opposite side over the adjacent side. So you guys, please write down these ratios so that you can have them in your notes forever and ever. And you'll be cleaning out your garage, and you'll be like, oh, this is where my notes went. Okay, so let me show you. This is just a memory technique. We usually say so, ka, toa. So is S is for the sine, O is for opposite, H is for hypotenuse. So it's sine opposite over hypotenuse. Ka is the cosine, and it is adjacent over hypotenuse. And toa, T is for tangent, and it is the opposite over the adjacent. Okay, so we're going to put together, so it says find the sine, cosine, and tangent of the indicated angle. Round answers to the nearest hundredths place. Okay, so we're going to do this twice. The first time we are going to look at angle S. So let's label our triangle, and just for fun, I'll show you my little man. This is why we did the little man drawing. So if you make a little stick drawing, here's our man. Hey guys. So his legs actually are the legs of the triangle. So here's his leg, here's his other leg. And the hypotenuse is always across. So the step number one is to label the hypotenuse. Okay, I'm going to erase him so that we can. All right, so we use the little mans to find the hypotenuse, which is 13. And if you have the choice, it is always the longer side. So the next thing we have to find is Is 5 next to angle S, or is it opposite angle S? And because it doesn't even touch it, it is opposite. And then 12 has to be the adjacent. So we choose, it has to be the opposite, adjacent, or hypotenuse. Those are the three choices. And we know sine is opposite over hypotenuse, so we're just going to put together that fraction. That's all this is. Opposite over hypotenuse, which is 13. Sorry, I got carried away with this. And then they want it as a decimal, so we are going to pull our calculator up and go 5 divided by 13. It is 0.38. Okay, cosine is adjacent over hypotenuse. Adjacent is 12. Hypotenuse is 13. 12 divided by 13 is 0.92. And then tangent is opposite over adjacent. Opposite is 5. Adjacent is 12. And then we do 5 divided by 12 is 0.42. Alrighty, now we're going to do the same thing with R. So we shift our focus to R. And then what that does is it trades these guys. So now 12 is the opposite side and 5 is the adjacent side when I'm looking at R. So we're going to put the ratios together for R. So sine is opposite over hypotenuse. We've already calculated what that is. Cosine is adjacent over hypotenuse. That's 5 over 13, or 0.38. And then tangent is opposite over adjacent. We have not calculated this one, so let's grab our calculator. 12 divided by 5 is 2.4. All right, so that's all that trigonometry is. It's just finding the ratios of your triangle and how the sides are related. Easy peasy. We are now going to transition. We're going to use those trig ratios to find some missing angles. Find the trigonometric ratios of the angles. Don't use a calculator. Okay, so this may blow your mind a little bit, but hang with me for just a second. So we have a 45-degree angle. So let's draw this. Okay, so we know that 90 degrees is there. We know that this angle is going to be 45 degrees. And then if we do our math, we go, okay, there's 180 degrees in a triangle. We have 45 of that taken up with our angle, and we have 90 degrees of that taken as well. So the last angle has to be 45. Well, we know that the rule of isosceles triangles is that if the base is the same, then the sides also have to be the same. Okay. And then it says don't use a calculator, so we are not going to use a calculator. Watch the magic that happens here. So we're going to use Pythagorean Theorem. So we got x squared plus x squared equals c squared. We need to find our missing angle, so we can put together the ratios. We did this in the previous section, so I'll do it one more time so you guys can see. So that's 2x squared equals c squared. You take the square root of both sides. Switch colors so you can see. And then c is equal to, well, x squared is x, and square root of 2, he doesn't simplify out. So this guy is equal to x root 2. Okay, now let's put together our ratios. So we have so, we have ka, and we have toa. So the sine of 45 degrees is opposite over hypotenuse. So 45 degrees, so let's go opposite. We'll use this is the hypotenuse, and this is the adjacent. Okay, so sine of 45 degrees is opposite over the hypotenuse. When we simplify this down, the x's cancel out. We get 1 over root 2. Unfortunately, we are not allowed to have square roots in the denominator, so we have to rationalize this denominator. 1 times root 2 is root 2, and root 2 times root 2 is 2. Okay, let's try cosine. Cosine of 45 degrees is adjacent over hypotenuse. Adjacent is x. The hypotenuse is x root 2. Oh my gosh, they're the same. Thankfully, we've already done the simplification, so this is equal to square root of 2 over 2. And then the tangent of 45 degrees is equal to opposite over adjacent. Opposite is x, adjacent is x. X over x is equal to 1. And you guys, this is true for all 45-degree angles, or 45-degree triangles. The tangent is always going to be 1, the cosine and the sine are always going to be root 2 over 2. If you have 45, 90-degree triangle. That's why they're special. Okay, let's do the same thing with 30, 60, 90. So 30 is my small guy. This will be my 90, and this will be my 60. Okay, so 30, 60, 90 triangle. Let's make our small side x. Our hypotenuse so in a 30, 60, 90, the hypotenuse is double the short leg, and the long leg is the short leg times the square root of 3. So we're going to put together sine of 30, cosine 30, and tan of 30. Put these little ratios together for you. So the first thing we have to do is identify the hypotenuse, which is a long side. It's right here. The opposite side is our short side, and the adjacent side is our long side. So sine is opposite over hypotenuse. So the opposite side is x, and the hypotenuse is 2x. When we simplify this down, the x's cancel, and I get 1/2. Yay! Cosine is adjacent over hypotenuse. The adjacent side is x root 3, and the hypotenuse is 2x. The x's cancel, and I get root 3 over 2. Yay! And then the tangent is opposite over adjacent, so that is x over x root 3. That gives us 1 over root 3. We are not allowed to have that root 3 in the denominator, so we are going to go ahead and times the top and the bottom by root 3, and we get root 3 over 3. And then these are true for all 30, 60, 90 triangles. The sine of 30 degrees is 1/2. The cosine of 30 is root 3 over 2. And the tangent of 30 is root 3 over 3. Okay, example 3. Find the value of the variable. So we are going to solve for D. Let me show you how this works. I just made a marker here. So let me show you how this works. So we're going to look at angle 28. D is the hypotenuse. It's across from the 90. And 14 is the opposite. It is across from our 28 degrees. So opposite and hypotenuse, when I have to choose between sine, cosine, and tan, sine, cosine, and tan, the one with the opposite and hypotenuse is sine, so we're going to use sine, is the opposite over the hypotenuse. Okay, so now we are going to solve this proportion. We put sine of 28 over 1, and we cross multiply. 14 times 1 is 14. Sine of 28 degrees times D is D times the sine of 28 degrees. We need to solve for D, because that's our missing side. So we divide both sides by the sine of 28. Divide by sine of 28. Let me show you how to do this on your calculator. Okay, so my calculator, number one, make sure you are in degrees, because we are in degrees. My calculator likes the number first and then the sign. So I know that the sine of 28 is 0.469. So I'm going to go 14 divided by the sine of 28. So the answer to D is equal to 29.8. And it is a rounding, so we have to change that. Okay. So that is how we use trigonometry to find the missing sides. So we're going to do that again here. So we have our angle, that's 18. 42 is our hypotenuse, and x is our adjacent side this time. It is next to our angle. So adjacent and hypotenuse is cosine. So we got cosine 18 degrees is adjacent over hypotenuse. So we put that over 1, we cross multiply. So 42 times cosine of 18 degrees is equal to x times 1. So in my calculator, I go 42 times cosine of 18, 39.9, and that is an approximation because we rounded. Yay. All right. When you are asked to solve a right triangle, you're asked to find all the angles and all the sides. Inverse trig functions, we use that to find angles when the sides are unknown. So let's go ahead and do that for these two examples. So when I have tangent of A is equal to 0.7, angle A is the inverse tangent of 0.7. And let me show you on your calculator how to do that. So my calculator likes the number first, and I have an inverse button. You guys might have a second. So that you go inverse tangent. And so our angle is 35 degrees. So angle A is 35 degrees. Make sure you guys are in degrees. So if I want to find angle B, and I have that the sine is 0.9, I go 0.9 inverse sine 64.2. So we're going to do that for inverse. So 5.4 inverse tan, 79.5. And then we're going to inverse cosine the 0.1. $84.3. I love it when I get these guys because we are just finding, it's just a calculator check. Okay, our last example is to solve the triangles. So we have 2, 3, hypotenuse we don't know, and we just know that we have a 90-degree angle. So we're going to find angle C first by using, side C first by using the Pythagorean Theorem, and then 13. So C has to equal the square root of 13. And then we're going to find, let's find A. So we're going to find A using tangent. I use tangent because I have a whole number for the opposite and the adjacent. So tangent is opposite over adjacent. And so I can find A by taking the inverse tangent of 3 over 2. 3 over 2 inverse tangent. 56.3. And then I can find angle B by subtracting 90, 56.3, and whatever's left out of that 180 minus 56.3 is our angle B. Okay, and that's how you solve the triangle. We're going to do this one more time. This time we have the angle, but not the side. So we know that this guy is the hypotenuse, this guy is the opposite, and this guy is the adjacent. All right, so we have, so let's find H first. Okay, so to wrap this up, we're going to go let's find H first. So sine 25 degrees equals opposite over hypotenuse. This over 1. Of course.
Good morning, Alvarado.
Okay, you guys, we cross multiply. H equals 13 times the sine of 25. And H equals, let's do that math on our calculator, 13 times sine of 25, and that's 5.5. And then let's go ahead and use Pythagorean Theorem to find our G. So we go minus 5.5 squared. G squared is equal to, let's pull up our calculator one more time. 13 squared minus 5.5 squared. 138.75. And then we got to take the square root of that. And then we have this, let's find the square root right here. So 11.8. So G is 11.8. And now I have solved almost this triangle. We're just missing G. So angle G is 180 minus 90 minus 25. Which is 65 degrees. Yay, and we have all the angles, all the sides. Okay, my friends, take a peek at the answers to all your homework problems. This is just the answers to all your problems. Pause it, rewind, slow it down, whatever you got to do. And that's it for today's lesson. Thank you.